Okay, so let's go ahead and review the lesson we did today. So we looked at height data. So where do you stand? So we had height of 20 random AP students in inches, and we wanted to see kind of what that distribution looked like. So we talked about this being symmetrical because even though we do have some gaps here, we identified there were some weird numbers. We want to make sure we understand that they're kind of equally weird, so they do kind of pull this into a symmetric distribution. Then we kind of looked at these two questions. So what is the typical height in this distribution? And so we kind of narrowed it down to like, well, most of the people are kind of here. But very specifically, if I kind of looked at the middle of that clump, that would probably be what's typical or kind of a common representation of where people are. Or if you think about it, it's just kind of your middle, which is your median. We also talked about the mean and the median being essentially the same here. So we said this looks symmetric, and then the mean and the median being equal also indicates that this is symmetrical. So there's not like one outlier pulling the mean one way or the other. They're pulling equally. So this is a symmetrical distribution. We can see it in the dot plot, but also we can compare with those numbers. So then we examine the phrase, if a person is only 66 inches tall, or if that is their height, are they considered short in this data set? And we had some mixed responses, but for the most part, we said not really, because 66 inches is here, and if our median is in here, then you're not very far away from the median. So generally 66 isn't too short. It's kind of right in the middle with everybody else. So we would say 66 isn't considered short. So the kind of that phrasing of only 66 inches, well, you can get rid of the word only, because 66 is right on par with, the pack here. Now, if I was only 62 inches, like my height, then I would say, yeah, like I'd be considered short. Because if you look, like the first quartile or quarter of the way into your data is 65 inches. So if I'm only 62, then yeah, I wouldn't even be 25% of the way into the data set. So I would be considered short if I was 62 inches. So then we examined these questions here in groups, and essentially kind of came up with some things. So we're looking at data. So what do we want to look at? Well, I did compute outliers. These are actually officially outliers if you want to compute it with the 1.5 rule. We described the data set, so shape, center, outlier, spread, with context. So the shape of the distribution of heights, there's my context, is roughly symmetric. The center, or the median, is 67.5. The spread, we can use the IQR, which is the difference in my quartiles, is 4.5 inches, and there appears to be an outlier at 55 and 78. Okay, the other option, since this is pretty symmetrical, the outliers are essentially kind of canceling out their pull one way or the other. You could pair mean with standard deviation to talk about the shape, to talk about the center and the spread. So then we kind of looked at where people fell in the data set. So Tessa is 65 inches tall. So this phrasing is important: who are less than or equal to her. So less than or equal to. So if I look at 65, there's one dot, and then 1, 2, 3, 4 more dots below that. So I have a total of 5 individuals I've accounted for out of 20, which is 25%. Now I can do that for anyone's height. I can pick any location in the data and then count what is at that point and below it. And when I do that, that's what we call a percentile. So it's the percent of the data that is where you are and less than where you are. So it's basically who is below you. So then we kind of examined this in a graph. So we did various ranges here in the data, and we counted up how many people fell into those buckets or those ranges, and we found the relative frequency, which is just a percentage. So people that were between 55 and 59, there was one person, so 1 divided by 20 is 5% or 0.05. And then cumulative relative frequency is everybody up to that point and including that point. So that would, for right now in this row, would just be this one person. But when I go to the next row and the next range of numbers, I would count 3 people between 59 and 64 inches tall. So 3 out of 20 is 15%, or 0.15 is my relative frequency. So I've counted 15% of data, but cumulative relative frequency now, like up to the second row, I've counted these 3 people and this person. So cumulatively, I am 4 out of 20. So 20% of the data has been accounted for. So less than and up to that point. And then we just repeated that process, noting that in this column, obviously at some point, I'm going to total up to 20 individuals. Eventually, I'll account for everyone if I keep adding as I go. So to make sure this is correct, you'd have 100% at the end. Now this part, we just made a graph out of that data. So I kind of went up by 5s here to have my intervals essentially represented from this chart. So these heights, I just went up by 5s. And then the cumulative relative frequency, these are just your percentages from this column. So I just went up by 10s. I went from 0 up by 10, so 0 to 100 here. And we have to make sure we start at 0, otherwise things will look a little distorted and we don't want that. So then from there, I would just want to kind of do my thing. So there was nobody at 55, like there's nobody less than that. So starting at 0, then we've got this first row to account for. So basically up to 60, not including 60, but up to it, essentially, I got 5%. So if I look at this dot, it's at about 60 and then, about 5%. And I just keep that process going. So then basically 65, I'm going to go to 20. So if I have 65 and then go, up to my 20 mark, and then 70, go up to that percentage, 75, go up to that percentage. And at the end, I should be basically at 100%, or 79. There's the 100, once I'm up to there, I have 100% of my data accounted for. So if we wanted to find my height, my percentile, just using this graph, I'd want to find my height is 62. So I'd want to go to 62 and then go over to the percentage. So that would be, if we estimate here, about 15%. So I would be in the 15th percentile. So that means there are 15% of people at my height or below my height in the data set. So I'm basically pretty short. This is just reconfirming what I already know. And then we could find any other percentage that we want. So some special ones we can find are quartiles, median, and Q1, median, and Q3, because those are essentially percentiles. They're just locations in the data. They're just special locations. So like my median is basically my 50% mark. So that's the dead center, literally the middle spot. So if I go to 50%, 0.5, 50%, and then go over and down, there's my median. You can estimate that spot. Same thing with the quartiles. Quarter 1, first quarter would be 25% of the data. So I could go to 25% here and go over and down. And I can find my first quartile. Third quartile is the 75th percentile. So I could go here, 75% and down, there's quarter 3. So you can find those special markings because they're just locations up to a certain point in the data. So kind of nice to find those special values when you need them. Now you can find any random percentile too. So like, let's just, for the fun of it, let's say I had 80th percentile. I could go up to 80, go over and down, and I can find what value that would be. So about 75, 76 inches would be 80th percentile. So 80, this height tells me 80% of people are at that height or below it. So that'd be a pretty tall person, for example. So that's essentially it for our data. So these are our important ideas. The formal definition of a percentile is the percent of values that are equal to or less than the individual value you're looking at. So basically count up the dots at that point or less than that point, or if you just have the data itself, count the data. Cumulative relative frequency is a fancy word for percent. So it's basically all the percentages, like all the data up to that point converted into a percent. And then here I've just kind of redrawn basically where my special points would be on a cumulative relative frequency plot or graph. So this would be kind of just an example data set. And then I kind of marked out where these special numbers would be. So quarter 1, 25th percentile, median 50th, Q3, 75th percentile. Now you could get your IQR from all of that as well, which we didn't do on the front side of the paper, but technically you could do that. So you could find your quartiles and then find the IQR from that data as well. So that's essentially what we did today. So percentiles and being able to interpret one of these graphs or find percentiles from the graph.